Hi, everyone. My name is Dmitry. I'm a partner at Archetype, and I'm excited to have a panel about verifiable compute with some awesome people. Let's maybe do some intros from my right.
All right. Hi, everyone. I'm Tina. I'm a co-founder and chief strategy officer at Fabric Cryptography. At Fabric, we're building the verifiable processing unit. So that's basically a custom general purpose chip for programmable cryptography across like ZK and FHE.
Hey everyone, my name's Steven. I work at RISC as the head of strategy. At RISC we've built the first and arguably fastest ZK And along the way, we've had a lot of exciting integrations, everything from ZK rollups to provable exchanges, obviously co-processors. And then on the side, we're building infrastructure stacks such as Bonsai. And moving forwards, we're building Boundless, which is our decentralized protocol that will hopefully power all ZK apps moving forwards.
I am Uma. I'm one of the co-founders of Succinct. We've built a ZK VM called SP1 that is also very fast. We've also built a OP Succinct, which is an integration with OP Stack that's running today to make any OP Stack rollup into a full ZK rollup for very fast, very cheap. And we're generally hoping that the future of all applications on Ethereum and other chains and all rollups will become ZK verifiable.
Nice. So maybe we can start off very high level. I think everyone in this room believes in ZK from a philosophical perspective, and just the thought of having mathematically guaranteed computational integrity is very exciting when you think about it. But I also worry that as the industry matures and grows, and then we start to have more outsiders come in, philosophy alone is not sufficient. I'm curious how you would frame the benefits of verifiable compute beyond just the philosophical argument. And anyone can take that.
I think in any system, you have to think about what are we trying to achieve. So the goals and the vision is like top level. And actually at the World Computer Day event, we had this talk about how performant should the world computer be. And I think one of the biggest discussion points was performance conditional on what? And I think one thing that's very important for me personally is that I think as a space, we have to remember we want performance. Of course, we all want the best performance, but it has to be verifiable. It has to be decentralized. It has to be permissionless. It has to be censorship resistant. All of those exist on a spectrum, but those are all very important. Otherwise, if you just have performance, but it's running on a single box, you're trusting someone, then what are we really replacing? I think performance is always in the context of a goal or a mission. And I think if we're building these trustless systems, we're building this world computer where you don't have to trust anyone else. You can just execute transactions, you can move money, you don't have to trust a government, you don't have to trust someone else. Then I think verifiability is actually super critical and definitionally almost needed. And I think so far as a space, actually, we haven't lived up to that. For example, I think a lot of the rollups we have today are not verifiable. They're just multi-sig. And I actually think as the space matures and there's like more regulatory pressure, there's more eyes looking at the system, there's more TVL, there's more dollars locked in contracts, verifiability will actually become more important than less because more will be at stake. And I think it's a critical part of crypto. It's like the foundation of all of crypto.
And I also think, like, speaking a bit more practically to what this means for developers, I think verifiable computation basically lets you separate consensus from execution. And what this lets you do for developers actually is it gives you a lot better functionality and expressivity. It's something I think we don't challenge enough, but at the end of the day, like EVM and SVM suck compared to like traditional programming paradigms. And verifiable compute, because they're able to take advantage of ZK and not have to think about consensus, you're able to actually do a lot more and build the sort of apps that I think people really want on chain and no longer think about things like EVM, on chain data structures and things like that.
Yeah, and taking it in another direction too, I think that verifiable computation is really important for basically like how humans relate with technology. I think a lot of the acceleration of technology that we've seen with AI and big data and things like that, like a lot of that's just not verifiable, right? Like you just have that and it's a black box. And it's hard for us as humans to really know what's going on, even though it dictates a lot of our lives. So I think a lot of like programmable cryptography is about expanding what we can know to be true and what we can trust. And like the internet wouldn't exist today without the last gen or the current gen of cryptography, really, like encryption, decryption, knowing who your data is coming from and that it can't be seen. But verifying an entire computation really expands what's possible and what we're willing to do in terms of relating with each other, like people we don't know, and just also just a huge, much larger range of use cases that we'll be willing to engage in.
So I generally agree. I'm gonna push and play bad cop for a bit longer and make the observation that a lot of the ZK rollups today, which 80 to 90% of proof demand comes from, if you check DeFi Llama, if you check Dune, those metrics don't look great. I'm curious what you all think is going wrong.
I actually think the story is very simple, which is ZK pre SP1. ZK is very difficult. If you founded a ZK rollup, you had to have 30 engineers grinding circuits, grinding these obscure crazy proof systems, and writing a ZK EVM. And even as like a founder of a ZK rollup, you have to be really good at cryptography. And often I think people are good at very specific things. So if you're super good at cryptography, that's 90% of your headspace. That's way less headspace than there is to go to market and engage with developers and get TVL and get apps and stuff like that. So I actually think it's unsurprising that given how difficult ZK was, given how much it delayed their time to market, that these people, it's a miracle they were able to get out a competitive rollup at all, honestly. And it actually makes sense that I think they're not doing that well. I think with ZK VMs, now you just have general purpose ZK. Now ZK is accessible to anyone. You can plug it into any existing rollup. And these existing rollups have had much more time in market. They have a lot more users. They have a lot more apps. They have first mover advantage. And you can just plug in ZK to them. And now every rollup can be a ZK rollup. It's just, and that broad thesis is actually true, is just not going to play out that only certain rollups have ZK. It's every rollup is going to have ZK, and the ones that were first to market that didn't have it, now will just have it.
I think like at the end of the day, and I love the ZK rollups that we work with, but like the UX improvements of ZK for rollups just isn't that impactful for users. You get the fast withdrawals, but most people will use cross-chain bridges for that. The cost benefit really isn't there because you end up having to pay still quite substantial proving costs. And if a lot of rollups are trending towards sub-cents, sub-tenth of a cent transaction fees, the ZK part of it just doesn't make sense given current performance targets. And at the end of the day, you're still restricted by consensus and all other things that rollups face. Not the best trade-off, in my opinion. And I think we've seen that with regards to applications and users. Everyone still goes on to base, and that makes sense.
So hello, Ventali. Thanks for joining us.
What's a question?
No, it's fine. Quick intro on yourself.
Hello, everyone. I'm Ventali. I'm working on Lita, and we're building Valida ZKVM.
Awesome. I think it's also a nice segue, kind of moving beyond rollups, to also make the observation that I guess for the three of you, your projects are choosing to build ZK VMs rather than ZK rollups. And I was curious what the design rationale was behind that.
Behind why we're not building ZK rollups, I think it's just like, one of the why we're building Valida is really trying to solve like a problem that we think hinders the industry from making faster progress. And I think building a rollup is more like an addition to the ecosystem rather than making a more fundamental technology sort of change. And also, I think it's more of a personal aspiration. Like we're just not very like interested in building like rollups, but yeah, it's just very simple.
Yeah, and I'd say like the overhead of building a blockchain is way too high. It's
Right.
also very siloing for all the applications on it. And I think at least amongst us three, our mission has all been to just prove as much as possible, prove the world software, things like that. And it's just our really good space for those sort of goals to succeed.
I would say I'm very positive on rollups. I think the biggest proof demand in the next few years is going to come from rollups. But I think there's going to be many flavors of rollups. There's going to be EVM rollups. There's going to be SVM rollups. There's going to be move, field, whatever. And then there's many different rollup stacks that have already come to market. They're mature. I actually think when you build a ZK rollup, the hardest part is building the rollup part, not the ZK part when you have a ZK VM. I think from that perspective, it doesn't make sense to focus on building a ZK rollup. I think it makes sense to focus on building a rollup. Or if you're a ZK team, it makes sense to focus on building a general purpose platform for ZK that any rollup can tap into. But I think there's no reason that a ZK, like those two things need to be coupled. And as a team, you should be building a ZK rollup. You should either think of yourself as a rollup team where you're serving applications, you're serving your ecosystem, you're serving end users, you're thinking about metrics like TVL, TPS, megagas per second. And then I think it makes sense to be a ZK team and think about how many cycles per second can I approve? How many kilohertz can I approve? What sorts of applications and rollup software can I approve? What's my cost for approving per transaction? But you're more servicing existing businesses rather than being like a consumer facing layer. And I think that separation actually makes like a ton of sense. And yeah, that's why we didn't build our own rollup.
That makes sense. And then you mentioned, and I agree that the proof demand will continue to largely come from rollups over the next few years. Where are all of you seeing demand outside of that? From your conversations from developers, where do you see the most excitement today?
Yeah, I'd be happy to take this on. Like, honestly, a counterpoint and kind of our thesis is if we reflect maybe just on the past year, like what protocols have generated the most amount of revenue, it's basically been DeFi, like Pumped Off Fund, all these protocols have been doing like hundreds of millions of dollars in revenue. And then as a business, I ask myself, who can pay for proving? Obviously, the protocols and the things that are generating the most amount of revenue. And subsequently, a lot of those people also want the most amount of compute. They want to make their apps more functional, more performance. And that's the direction we've been targeting. So a lot of DeFi apps, we've been working closely with Hashflow with this idea of provable exchanges. And yeah, I think DeFi apps, those guys have the money, truthfully, at the end of the day, to pay for proving. They also have real use cases where the amount of cents they put into proving also translates to better liquidity efficiency. So it's like a good pro and con sort of balance. And that's by far actually where we've seen the most amount of proof demand, probably arguably more than rollups, at least for our team.
Nice. And to the extent it's public and you're comfortable with digging in, would love to learn more about those use cases.
Yeah, I can talk about Hashflow. I love their team, and principally what they're building is a fully off-chain order book. In some ways, you might as well think of it as Binance or Coinbase. And then all the bids and asks, as well as the order matching, are proven in ZK. So you get this sort of trustlessness that FTX never gave you. And then for the user, they have gasless bids and asks. They can do deposits and withdrawals directly on the Ethereum layer 1. And the only downside there might be is there's this sort of hard finality that's triggered by these proofs that lag behind a few hours. But what you get on the UX side is basically the exact same interface as using Coinbase, but it is in a lot of ways trustless, although it's not fully trustless. There's definitely additional trust that, say, Uniswap doesn't have.
Awesome. Any other use cases that have popped up for y'all?
There are teams building like ZK-TLS. This is pretty interesting. And so later, like Flashbots is hosting like a T workshop, and there are a lot of ZKT sort of little projects coming out. And we've seen like a couple of teams trying to build like trustless, or it's a ZK-P2P team. They're building, there's another team that's building like a ZKT-TLS sort of protocol, trustless via on-ramp protocol. And I think those can drive tremendous amount of volume as regulation becomes more clear, but pretty bullish on payments just in general.
And my understanding for the ZK TLS use case is the ZK part is more around a compute compression type use case, but I don't know if you have any more insight into what exactly the ZK component in the ZK TLS use cases are.
I think there is one project, it's a recent protocol called Oracle, that's sort of a TLS there, ZKT TLS. I think the ZK part is proving the authentication tokens. And I'm not sure about the other ZK TLS protocol. I think there are only 2 or 3. Yeah, very few.
Yeah, I agree. ZK-TLS and ZK-P2P are super exciting. I would say the 2 ways that ZK can be used that are, in addition to scaling, would really be like ZK-TLS, like connecting like Web 2 data into Web 3. I think that's really going to be important for the future. And also just like improving the UX, like through unifying liquidity, for example. I think those are really interesting directions.
Any other use? I think that this is super important, just to give everyone an understanding of like where developers are exploring the design space. And maybe it's just 2 or 3 today, but I'm curious if any more have popped up from your conversations from developers.
I think the Cursive team is building pretty cool stuff. I think everyone knows them, and they built that trustless LinkedIn thing, helping engineers find their recruiters, find companies in a partially confidential ways. And I think that's pretty promising. That can be expanded to other products as well, not just LinkedIn, hey, Tinder or something like that. It'd be cool too. Yeah.
Personally, I'm also pretty bullish on coprocessors. I can't really name the teams we're working with, but it's just very simple. If I want to do 10,000 Merkle root calculations on chain, it's impossible. And using ZK is a very simple application for that. They're able to do computation that used to take 1 billion gas, and they're doing it with 250K gas plus a few bucks in proofs. And there's quite a few teams, some voting teams as well, that are using similar architectures for their stacks.
Nice. Good stuff. Yeah, maybe we can go a bit deeper into your individual projects. One observation I had is that for RISC-0 and SP1, you're targeting the RISC-V ISA. For Lita, you're doing a custom ISA. I'm curious what the rationale was behind those design choices.
Yeah, the RISC-V ISA that both us and RISC-0 target, I guess for some background and context, it's an open source ISA. The particular variant we target is the 32-bit IM variant, which means it's like all the words are 32 bits. There's also a 64-bit variant. And the nice part about the RISC instruction set, the R stands for reduced, is that it's very small. So I think there's 30-something opcodes. And that means that when you have to do a circuit that proves the execution of a RISC-V program, it's still very complex and annoying to implement, but it's much more simple than a instruction set like WASM, for example, that has 100 or something like that opcodes. So I think the small instruction set makes it easier to implement. Also, the instruction set is a backend of LLVM. For example, Rust and C can all compile down to this instruction set. Now in practice, people mostly just use Rust, and that's a very popular language that you have Ref, Revim, Alloy, like a bunch of Ethereum Rust tooling, a bunch of Solana Rust tooling, even like Tendermint Rust tooling, whatever. Yeah, you have really great language support. It's simple to implement. I think it makes a lot of sense.
Yeah, I think ISA is probably like the differentiator of Lita, and we really think that ISA is the core architectural innovation. And I think it's a good analogy to think about ISA as a brain that it's a command center that sort of controls how a person controls its body and functions. So ISA it's like fundamentally like how you do data processing, how do you do instruction handling and execution speeds. And Lita is really like so it actually shares a lot of RISC features, and it's like an ultra RISC instruction sets where it shares a lot of design ideas of RISC but it further shrink down to about like 30 instruction sets that are super sort of ZK optimized. In some cases we see like 1.5x ISA efficiency. In some cases it's 5x or more, and it tremendously reduces the instruction efficiency of running programs under cryptographic constraints. Yeah, that's the rationale. And we're also building, right, like our LLVM IR2 Lita ISIS compiler backend is pretty stable right now. And so you can also write Rust and C without compromising compatibility with existing softwares. Yeah, that's the rationale behind just more performance.
But I assume, that nothing comes for free.
Yes.
So I guess not having an existing tool chain is like one challenge. What other challenges are there with your approach?
I think the biggest challenge is the compiler. And we've spent like 1.5 years building this, and now it's like stable, and we're still, for each language, we have to support build systems, and like C and Rust and Go are different. And so you have to work on specific languages as well. I think it's just a lot of work, but that's, yeah.
And maybe from a hardware perspective, is there any, or what's the effect from a hardware perspective? Does the choice of ISA affect the I don't know, compatibility of the underlying hardware, or is it just a tangential point for you?
Yeah. So I think if we were building an ASIC, like this would be a big deal, right? But from the beginning, we wanted to be proof system agnostic. And fundamentally, if you have a RISC-V ZKVM or if you're using Velita, you're going to need NTTs, you're going to need hashing. So those fundamental building blocks, our architecture is very flexible to that. It's kind of, it comes down some to software integration, but nothing on the architecture side. Yeah.
Nice. And maybe a good segue for everyone around how you're thinking about hardware more broadly in the context of the current proof systems that you are using and your future roadmap.
Yeah, I can start. Generally, I think there's CPU that's just like the bread and butter of proof systems. You have a CPU prover. There, you can implement like multi-threaded versions. You can implement certain instruction sets like AVX that are very optimized on certain CPUs. But I think ultimately most projects progress to GPUs because on a dollar basis, you just get a lot more flops. So both us and RISC-0 have a GPU prover that's a lot more efficient than our CPU prover. And it's a lot more efficient in that it's both cheaper and it's also a lot faster. So it's not like there's some trade-off of fast and cheap. It's just better on both dimensions. Now, obviously, you can't do like GPU on your phone or something like that, right? So it doesn't work for all environments, for client-side proving, for example. But yeah, generally for really beefy use cases like rollups or these like provable exchanges, everything's being run on GPUs. And I think all proof systems will need to implement a GPU prover. And then I think there's like the future where there's like teams like Fabric, there's teams like Irreducible, and other teams that are building custom hardware. And I think that's really promising and very exciting. I guess some of the challenges of custom hardware is that the end proof systems, it's not super clear what the ending proof system is. I think us and RISC-0 and Lita all use Starks and univariate proof systems and Fried. It's all relatively similar. But in the future, maybe that's not the case. I think there's like the Andreessen team built Jolt, which is like quite different. The Irreducible team's really into binary fields, quite different. So that's one challenge with hardware because it takes a very long time to develop hardware. It's very difficult. It's very expensive. But yeah, if you have very smart people working on it, then I think it's very exciting and can be like a huge order of magnitude gain on efficiency.
And is it like in order of operations? Does customized hardware follow the proof system itself, or is it vice versa?
I think it's a co-design question, right? So for us, we looked at all the existing proof systems when we first started Fabric last year, and we figured out optimizations or just figured out how the data movement would work through the chip in a way where you have the maximum performance while making it still as configurable as possible. And a lot of that is like looking at the fundamental like mathematical operations and just figuring out, okay, like what parts of the pipeline can be reused, like which things, like we do have a few hard-coded things like, well, really just like custom instructions for hashes, a bunch of custom instructions that we built from the ground up, like our own ISA basically for cryptography. So I think that like when you first want to make a chip, obviously you have to follow actually exists already. But like we've also been working, we have collaborations and partnerships too, where a lot of it is co-design, right? Where we work together, we look at the proof system, we look at the future direction as well, like what they want to add. And those are instructions that we actually have added into our chip. And so like our RTL is like frozen. That's like like our design for our current chip is frozen. Like we're in the late stages of the tape out process now. But I think like we're pretty confident that the proof systems for the next few years, like we're pretty confident. And then I think like it's also really exciting to start looking at the design for the Gen 2 of the VPU. And I think that's just will be a really fun like conversation to think about what to add, what to improve. Yeah, and I think that's some optimizations could definitely happen on the proof system side. And for sure, we're always happy to change things up as well.
Awesome. And maybe a good segue into looking at some of the proof systems you mentioned, Phineas, Lasso, Jolt, all the different folding schemes. I'm curious how all of you are looking at those innovations and to the extent, are you integrating them into your roadmap or is it something that's more long-term? yeah, curious to hear your thoughts on that.
We're looking at all of them, but at the end of the day, I think there are too many easy, low-hanging fruits we see on a roadmap. Easy 2x's, 4x's. Once you compound those, you get those 10x's that some of the innovations promise. That we basically are going to be busy for the next year, 2 years, really focusing on that. Long term, opinions make sense. A lot of these innovations make sense. Who knows what else is going to come out? But if I were to look at our roadmap at least 1-2 years out, it's purely focused on low-hanging fruits, getting those 2x's. Yeah.
Yeah, in the past month, we 1.5x'd SP1's performance. So I do agree with Steven's point on low-hanging fruit. I think ultimately there's algorithmic improvements and cryptography improvements, and then there's like proof system engineering improvements that also there's often a big gap between theoretically what's very performant and then practically how fast can you engineer it, how close can you get to that theoretical bound. That being said, I think I maybe am like much more optimistic on all these different proof systems. I think we're always continuously evaluating new proof systems. I think we have a very scientific process of benchmarking them, figuring out what's most promising, exploring different directions, running controlled experiments based on those results, figuring out a small POC. And I think I'm very optimistic that at the proof system layer, we're still not done. I think on the engineering side, we're always innovating, but I think there's actually still a huge order of magnitude to be gained out of the proof system, and we're always exploring those.
In terms of integration, I think we are thinking about potentially maybe using voting without homomorphism for recursion. But for Venus binary fills, I don't think we're planning on integrating for now. It's always an option. And I agree from the company strategy perspective, it's makes more sense to look at the low hanging fruit and as well as planning for the future more algo optimizations. Yeah, both are pretty exciting stuff.
Maybe as a last question, having something more forward-looking, when each of you look at the verifiable compute landscape in 3 years from now, what do you think would be the biggest difference relative to where we are today?
I guess our like motto is prove the world software. And I think right now, as a company, we're focused on proving the world's rollups. That's a very specific type of software. Now, rollups are a general purpose environment where many developers deploy many different types of applications and many different types of software. But I think in the next 2 years, I'm really hopeful that we'll complete the rollup mission. It'll become normalized. And then we can start seeing like broader adoption in more different categories of software. So I think it's like rollups, blockchain, crypto is the early adopter of verifiable compute. Like any industry, there's always like the early movers who have a very burning problem. And I think the rollups have needed this technology for 5 years. And now it's finally here. And like they can stop being multi-sigs. They can stop having the 7-day withdrawal. Like we can get rid of all that technical debt and make it work. And that's why it's a very burning problem. And that's why it's a really big market today. But then once that's solved, it's okay. That's obvious. I think there will be a lot more applications that can be verified that will be interesting. And I hope in 3 years that's where we are, where we're like on this panel talking about stuff beyond blockchain, beyond crypto, beyond rollups.
Yeah, and on our team, we're like in a similar vein, very focused on bringing the internet on chain. There's a lot of stuff on a roadmap yet to be announced that will basically make it super seamless to take your existing software and prove it. When I think about it, what ecosystem in the past 20 years has really exploded with apps? And the only one I can think about is your mobile phone. And how do you take like where apps are and bring them on chain? I think ZKVMs are really well positioned to do that. And yeah, like things like Polymarket really just show you need to ask yourself at the end of the day, what actually needs to be on chain? What really benefits from the principles of decentralization and consensus? And what things don't? And the things that don't can remain off chain, and ZK will be a great bridge connecting the internet and all of those apps with the things that actually are worthwhile to put on chain.
Well, I think 3 years from now will be like VPU Gen 2 will be out, maybe VPU Gen 3 or we'll be working on it. And I think something really exciting is just doing like node shrinks, updates to the architecture, like being on 5 nanometer or even 3 nanometer. Like that would be super exciting. That would be like at least 2 orders of magnitude improvement. So I think at that point, we'd be like performance would essentially be a solved issue, right? And I'm hoping, like, I don't think like the demand for compute would really stop, but it would basically be like if performance is solved, everything's real time, right? and cost is not that big of an issue, like all of that can feed into UX. And I'm super excited to see where that goes. And yeah, and I think just like future just use cases beyond blockchain as well. And but also I think just seeing really cool decentralized use cases that are super computationally intensive but wouldn't be able to exist in centralized context. I think that would be like super cool to see as well.
Yeah, I really hope that ZK can go beyond crypto, blockchain. And I think in 5 years, it's possible that as AI, robotics, more automated software sort of start to talk to each other, hope that SDK can be a crucial part of that. And that would be super exciting, not just proving roll-ups.
Nice, love it. Yeah, it'll be great to look back at this in a few years and see how right we were. I think we're at time. Thanks, everyone.